back to the tutorial. That means today we are going to see the new series called deep learning. Under deep learning, we are going to discuss about convolutional neural network. So before that, you have to get idea about what is deep learning. So as of you know, today if you go for research work or anything, where are you have to you have to know the term called machine learning. From the machine learning, you have to know the things like ANN, that is artificial neural network. So and then if you go deeply, again you come out here, you can go for the subdivision of ANN called convolutional neural network. So before that you had now the deep learning. So generally as of you know machine learning is there, but one of the another term called deep learning. Here the term deep means usually refers to the number of hidden layers in the neural network. That is the meaning. So as of you know, even though you have machine learning, we are go for the deep learning models also, because these are trained by the large set of labeled data, and also here the you can replace. So without human intervention, we can work with we can give the training to CNN and deep learning model. Any deep learning model we can carry forward with the help of CNN also. So remember, so deep learning is a term, sorry, it's a term or form comes under the category of machine learning only. From the deep learning we have something called ANN, CNN and so on. So CNN, so for CNN the basic is ANN only. That is artificial neural network only. Thing you have to remember. So let's go for the CNN now. So we have to see today the introduction to CNN and what is exactly CNN and how does CNN recognize the images and how the layers in the convolutional network support us to develop any model, anything like that. So as of now, have about deep learning model. If you have about deep learning, how the works like that, we can easily understand about the CNN. So CNN, just now I told you introduction. So what you can say, before the CNN, you have idea about computer vision, because one of the branch within computer science that enable computers to recognize the visual world easily. Let's move for find options. Yeah. So what you can say, though so many deep learning models is there, the convolution neural works by getting an image. So if you go for CNN, we can go for image analysis generally. Not only image analysis, you can go and develop the CNN for recognize the video, audio, or anything, even large data, complex data also you can handle with the help of CNN. Remember. And so before going this deeply, so what is CNN like that? We have now some idea. There are plenty of definitions available, so we can remember and easily understand. What is CNN? You can say it's a just network that uses convolution. So convolution means what? Some mathematical function. You can say simply. What you can say is convolution means with a mathematical function. Moreover, we can apply this CNN to a filter to an input to create a feature map that summarizes the presence of detected features in the input. So this is a small neural network given example. Before get idea about this convolution network. So let's say we have two flowers, orchid arrows. How we can identify with the help of this technology? So we can go for input layer, hidden layer, and output layer, and orchid arrows. After giving the training, we can come out the solution of neural. This is a general one. Before introducing the CNN, let's cover introduction of CNN. So again repeating, it's one of the familiar feed forward neural network also. And if you want to understand ensemble learning or transfer learning anything, we need support of convolutional neural network. Here, so as of you know, here CNN, what happened? Every image is represented in the form of array of pixels values only. So images are how the computer visualize or understand, start to understand means this is a real image means it take as pixel values, form of array pixel values, then start to arrange as a 0 1 form like that. Then the convolution always form the base of neural network. How the work using two matrices? Just now tell you convolution means, just to remember, it's a mathematical function. Let's assume that you have two matrices called A, consists of the values like 5 3 7 5 9 7. Another term called B 1 2 3. Now if you perform the convolution operation, what will happen? Nothing. You can say the arrays are multiplied element wise and the product is summed to the create a new array which represents the A multiplies B. So remember, and again repeating, if you have CNN, you can train the computer with model algorithms where you can predict. Suppose I want to categorize, suppose two images, cat and dog. So if I want to predict and find out which is cat and which is dog, the time of that that time also you can move for the CNN only. So here there are the first three elements of the matrix are multiplied with the elements of matrix B here. So product is summed to the get result. Let's see the one. So this is the one. So A, B. So before understanding the technically the images recognition, we have to understand this theory part. Then only we can get strong knowledge in the CNN. So multiply the arrays, then sum the product like this from here. The next three elements from the matrix are multiplied by the elements in matrix B and the product is summed up. So we need little bit mathematics knowledge for a better understanding the CNN. So like this, we'll get the answer here. A, B, that is 17, 22 and so on. So just remember, so image is there, image are consists of a pixel, the computer, and also remember if you go pixels and everything, the images are it may be RGB or gray color image. Whatever there, you can give training in the based on CNN model. Then you can come out how does CNN recognize images. So let's assume the real image like this. The representation in the form of black and white pixel. So the CNN start to work out with the help of this one, understand in the form, represent the form of black and white pixel. Then the image represented in the form of matrix of number just now 0, 0, 1 and so on and so on. At last go for the predictions. Now what exactly in the CNN? So if you think about CNN, there will be four layers there. One is called convolution, another called ReLU layer, another called pooling, another fully connected layer. So convolution, the term operation. So every image is considered as a matrix of pixel values. Let's see the image. So this is the image where you have a 5 into 5 image whose pixel values are either 0 or 1. And also there will be a filter matrix that the dimension of 3 into 3. So we can go like this only. So convolution the first step. So suppose I want to train, suppose I have data set and if you have data set you can train and increase the data set and go for convolution, then go for the step of future you can go for ReLU, pooling, fully connected, that means future extraction and so on and so on. I'll give you 2 or 3 examples where we get more idea and later go for implementations with the help of Google, some Python coding. Say ReLU layer. So one of the best ReLU is nothing but a activation function where once the feature maps are extracted, the next step is move them to a ReLU layer. Moreover, it performs an element-wise operation and set all the negative values to 0. Remember, so all the negative values is 0, and also it supports reduce the non-linearity of the network, and the generated output is rectified feature map. That is the graph of the ReLU function. So ReLU function always try to remove the negative values. Remember, so ReLU is activation function where always remove the negative values in the input area. So one where we have input, so we have to predict whether is bad or not. So once go for future map, the CNN start to work and after applying convolution and ReLU, it show like this, and again going in the extraction, it is a future map like this. So you can easily recognize and go for it. And input feature map. So when you get the input feature map, after extraction go for rectified feature map. This is the one. If any white positive value showing, black negative, and ReLU. After applying the ReLU stage of ReLU, only non-negative values. So again remembering, there are 4 things are important: CNN, convolution, ReLU, pooling, at last fully connected layer. So here go for it. After ReLU like this showing, so then after go for a pooling layer, we can say what is pooling is nothing but is a downsampling operation that reduces the dimensionality of the feature map. That means reduce the data set. Remember, if you go for CNN, all the data should be in same size. It may be anything like just now I told you 320 into 320 or 520 into 520, like that only. So here the map now goes through the pooling layer to generate a pooled feature map. So this is like rectified feature map. From there go for 2 into 2 filters and straight 2 for pooled feature map like this. So we are going to, what are the maximized feature map is there, we are going to get the pooled feature map here. Let's see the pooling layer. After using the pooling layer is important because it uses various filter to identify the different parts of the image like edges, corner, body, feathers, eyes and black. So this is the image. Where is the body? What are the image? It may be a bird or it may be a car or anything. It go the corner, every part of the image like edge, corner, body, everything. At last go for the result. That means predict and go for the result at having pooling. And moreover, here the next step in the process called as platooning. This part is platooning means nothing. Is you can say a one operation used to convert all the resultant two-dimensional arrays from the pooled feature maps into a single long continuous linear vector. So I just now told you we need some mathematical knowledge to understand CNN. Just some basics only. So go for predict. At last you go for prediction. So pooled feature map plotting. After plotting, we'll get the result like the 6, 8, 4, 7 like that. So now we go for the exact way. Suppose you have input image like this is a overall architecture of CNN. Understand whatever the data set, whether here image data set or audio, say audio, video, anything. General thing it consider the input image, then go for the stage of convolution and for pooling. After pooling and pooling, we have one more thing called maximum pooling and average pooling also. So if you want better result, you go for maximum pooling, and some result means we need support of average pooling and flattening. After flattening, as just told you, the deep in the sense what I told you, neural networks, lot of neural layers will be there. Even see also lot of neural layers will be there and connected with the weight and bias. Remember, and here ReLU, we are applying ReLU here. Just go for the example. Pixel from plotted matrix filled as input. After applying, we can consider this is the bad. Like the after go for applying the full connect layer, we can conclude the thing called this is the bad. So if you show bad, bad means bad. Whatever the given based on the CNN. Let's now see the question arises: how exactly CNN is against the bad? So we need answer. So just now I told you how it say the machine can understand, the machine or CNN model can understand say means there will be few things are important. It is called the pixel for the images are fed to a convolution layer, then performs the convolution operation. So it represents a convolution map. Just now I told you it's the basic architecture for understand CNN, any CNN model, and here the image is processed with multiple convolution and ReLU layers for locating the features, and different pooling layers with the filters also used to identify the specific parts of the image. So this image how like that's how like images corner everything, and the pooled feature map is flattened and fed to the fully connected layer to get the final output. At last it recognizes the alpha fully connected layer is recognized. So remember convolution, ReLU, pooling, at last the fully connected layer saying it's a bad like that. Remember, but real time in scope implementation, it will say that the accuracy is very important. It may say 80%, 95%, also, and so on. So, how exactly you can is? So, this is one convolution, ReLU, max pooling, fully connect layer. At last, come to the convolution of bad like that. This is the classification of the classification in the output layer, which extras in multiple hidden layer. And remember, why today deep under the deep learning is successful because it handle large number of data. Remember. Thank you for watching the video. If you like the channel, please subscribe and share with friends.